Hello. Hiya. Thanks for having me. What do I do usually or what do I do now? So basically, I am an Android developer relations engineer or DevRel. My name is Simona
Wait. No
Yeah, it's a
audio.
mouthful. Okay.
Please.
I was like, I instantly got scared. I was like, no, not again. Okay, cool.
Oh, it's this for echo
yeah?
for Ivan and
Now they can
Simona.
hear
Okay.
me.
There's
Sweet.
also echo.
Yes, I'm fixing that. That's now fixed. Go ahead. Sorry. I was saying, welcome to Code with Italians, where things never break and it's always my fault. Okay. So, today we have a new guest with us, Sim. Sorry. Can you do the introduction again?
Yeah, sure. I'm really glad that something broke already because now I won't feel stupid when we do
Nah,
something
nah.
and I break something. So
When something
perfect.
breaks is my
Perfect
fault.
introduced.
That's what I do.
Nice. Cool. Yeah. So my name is Simona Stojanovic. I'm an Android developer relations engineer working at Google. I'm part of the Compose team, and currently I'm taking care of areas such as layouts, which is a very broad and undefined area where whenever you don't know if something is something, you put it into layout. So it's super nice. And I take care of navigation as well.
Nice. So before we get going with the meat of the episode, let's have Ivan do the Ivan thing. Come on, Ivan, go for it.
Yes. Excuse me. So, good evening, beautiful people, and welcome to another episode of We Do Things Good at First Try. So, it never happened. I'm just bullshitting. So, thank you for supporting the show. No matter what, we have a surprise today for Black Friday, and we have new swag. So, if you bought already everything else, we have new t-shirts and
Yes.
new hoodie. We also have a code that you can use to save some money, and you are literally taking out the whole margin that we have on merchandising. But yeah, so you are
We are
paying
good at
the
business,
thing.
is what I hear.
Yeah, we are so good at making money. So if you use the Italian Friday code, basically you are paying the cost of the stuff, so at cost. So that's and it's made in Italy, and it's basically organic cotton. It's the best that we could find in Italy. I'm gonna just paste the links in the chat so you can check out the new stuff. It's plenty of stuff. And for the first time, we have hoodies. That's actually cool for winter. And you can support Code with Italians in a probably a lot of ways. Prime subscription. If you have Amazon Prime, are you showing the t-shirt, Sebastian?
Now I am. Why do you have to
Ba-bam!
spoil everything for people?
Sorry. I never know if you are. So we heard your feedback. So for we need to step up our theming game, and that's why we have also now we have dark team and light team on the t-shirts because we got so much feedback on at DroidCon London that it was like, you know what, let's just do it. So this is the new stuff. The usual support. You can subscribe on Coffee. There are plenty of tiers. One of the tiers, check the perks, is gonna. I love this. Yeah, the dog is on the couch. Here you go, bum.
Aw.
So the check for the tiers on Coffee, because one of the tiers will allow you to access the Discord server where we share things a bit earlier for subscribers, and where we share the link that you will use to join the private Google Meet at the end of the episode, where we create thumbnails for the episode where we have the guest, and if you want to ask, like direct questions, you have access to the guest of the episode. And yeah, that's it. Let's go. I want to see this now.
Are we ready for mayhem? Oh yeah, before we start, Ivan, can you put the Slido link in the chat so people can ask questions there? So as
Absolutely.
usual, we collect questions on Slido, but not only questions, you can also upvote the ones that people have already asked so that we know how to prioritize, because sometimes we have a lot of questions and we don't have enough time to answer all of them. So it's in your interest to make sure that the best questions have all the best votes, or all the votes regardless. Okay, so Sim.
Yes. Start.
Let's start.
Let's start. Sweet. Okay, so I guess maybe opening up the app that we're gonna show. Yeah, sweet. Okay, so yeah, for today, as we talked and announced, we're gonna talk a bit about custom layouts in Compose. And I think like as much as we'd like to, the best way I think of kind of displaying this and showing this and teaching this would be through an actual example. So we are going to be using the jet-lagged Compose sample. It's the latest sample that we've added to our Compose samples that we've had over the past year or two. So this jet-lagged sample, as you can see, is a mini app that tracks and displays users' sleep tracking data. And yeah, that's pretty much the gist of it, I would say. This specific app showcases a number of things from layouts, but also from graphics as well. So like things like displaying gradients, animations, drawing things on screen. So there's like a lot to it. For that part, we're not going to be talking about that today because first of all, it's not my area. I don't know it that well, and I don't want to get embarrassed. Second of all, we're going to be doing custom layouts, which on its own is quite a massive area. So I think we could just focus on that one because, yeah, it's going to take us a while to go through all of it in more depth. For those who are interested, you have the sample code up there, and you can take a look at it on your own. And I can actually, yeah, maybe share the link. I'm going to share it like this.
Yep.
And
okay.
We also have an ADS talk on this.
Yes, I have the link ready. I was
Cool.
just getting it. So
Sweet, yeah. We can share it now.
I'm
We
gonna
can share
put it
later.
in the.
Sweet.
And there you go. Okay, so we have both of the
Yeah.
links in the chat right now. If you're watching this on YouTube, we're gonna have the links in the description. Oh man, oh god, I hate saying that.
Yeah,
In the
it's
description
happening.
below. I
It's
couldn't get
happening.
myself to say it.
It's happening.
I had
Link
to
in
stop.
description. Link
No.
description.
At least it wasn't a sponsor. It wasn't a sponsor.
It happened. It happened.
That alongside the Black Friday, sponsorship. I think you're becoming mainstream. Yeah.
Yeah, we are there. I mean, I'm waiting for just like a sponsor, like a deal that they're like, oh yeah, this thing is sponsored by VPN.
Italian cotton.
Because, yeah, it's like
nice.
So I'm waiting for them.
Sweet. Okay, cool. So yeah, that's I think kind of an introduction that we can start off with. So I think maybe the next step, because we're gonna be going through how to build this specific screen, this mini sample that we have here, I think it might be worth maybe going over what specifically we want to build and how we want this behavior to be. And then we can kind of dive into the code maybe for.
So should we show it off? Because besides looking pretty, I think there's other stuff that is cool, like this transition here is very nice, but it's not what we're gonna do today because the funny stuff is right here, right?
Yeah.
Where we have this custom layout component where you have all the labels, you have the timeline at the top. And then you can click something to get this incredibly nice sleep phases visualization. And I've seen the ADS talk, so I know some of the black magic behind it, but I'm looking forward to actually playing with it.
Yeah, that's, I mean, the thing to keep in mind though is like a very official disclaimer. This thing you just said is the prettiest, like the best looking. That's the part we're not gonna cover. But
I know.
that's fine. You can
But
take a look at the code. Yeah,
that's why I put the link to the ADS
exactly.
video.
Precisely. I'm just joking. I mean, the custom layout on its own is really cool. It's like two different parts of an app. And I think both of them are kind of cool.
Yeah.
Depends what you geek about. Cool. So, okay. So yeah, for us, the custom layout, like there's a bunch of different elements to the screen and people can take a look at that if they want to from the actual code. But for us, for the custom layouts bit, we're actually going to be focusing on the graph itself. So we're actually going to focus on the labels that show the time at the very top. Yeah, the yellow one, exactly. The day labels that are shown exactly, precisely. And also, I need like a laser pointer or something. You know,
Yeah,
like, something
you
to
can
kind of-
virtually move my mouse pointer by saying up, down, down.
Nice. Yeah, and also the sleep bars, as we call them, which are the actual bars in between those two labels that display the user sleep patterns. And like you said, when you tap on a bar, it actually expands to show the different sleep periods or the different sleep types. So yeah, that's kind of the gist of it. To tackle, I guess, the first question here, which is something that I think people were interested even during the ADS talk, is why use a custom layout here? First of all, because we want to show how custom layouts work, right? So we have to display it.
Fair.
That's good reason.
Exactly.
Yeah, because we have a hammer, right?
Exactly. We want to do it. This is how we do it. We invent a sample that's going to be, a good fit for it. Second of all, is because even though it might not seem from just showing the sample like this, you need to have a layout here that's going to have a lot of coordination between different elements, right? So pretty much every element in this layout, these three main elements that we kind of discussed and showed, every single element kind of depends on another element for its own either measurement, so for its own size, or for its own placement, right? So depending on what time the user went to bed, on which day, those two informations are going to actually define the sleep bar, its width and its position and its starting offset. So there's going to be, a lot of coordination between these elements. Every single element needs to know something about the other one. And that on its own makes it a bit more complex for using regular composables, the ones that we have out of the box. You could technically do it like that, but you need to do some really heavy, calculations, some mind-numbing, ifs, when, thens, and
We
exactly.
don't like
So exactly, precisely. We want to do it in a clean way, and Compose the way it works. Like custom layouts are essentially made in Compose in a way that you can use them in a very easy and like super simple, straightforward way that's going to be super readable. So this kind of a layout is actually something that you can do in a very short time and then reuse it wherever you need it. That's pretty much how we're going to build it in a more reusable kind of a way, so that you provide some data and the custom layout just displays it for you.
Got it.
So yeah, that's pretty much like one of the main things I think you need to think about is like, before you dive into coding, just think about how custom you want to go. So how much you actually want to open up your layout for reusability, or if you want to make it super custom to your use case. So that's like one step to think about before you dive into coding in this specific example.
And I guess that's very important, because making a layout that is very use case specific makes it much easier, because you can cut a lot of corners if you already know exactly what you need. Whereas if you need to do something that needs to be used by everyone for whatever, then you need to consider a million different variants, all the possible things that can change, go wrong, whatever.
Exactly. Yeah.
So
precisely. Yeah. Exactly. That's, I mean, we kind of, for this sample, we went in like somewhere in between. We made it, like we try to balance it for the sake of showcasing this and showing a sample. So we have kind of a balance between the two. So it's not fully custom, but it's not, yeah.
I can copy paste it and use it somewhere else, is what you're saying.
Yeah, you could. Yeah, pretty much you could. Maybe you need to, tweak a few things depending on your use case. But if you want to do like sleep tracking or something, yeah,
I'll
depending
change
on
the
the data.
colors.
Yeah, you can change the colors. Yeah, you can change the colors. Just be careful with the license that we have there.
Isn't it Apache 2?
I'm kidding.
Yeah, it is. It's fine. Yeah.
It's fine.
We'll just say thanks, Sim, in the open source
Exactly.
section.
Sweet. Cool. Yeah. So I think that's pretty much, I think, enough for the intro, I would say. We can maybe dive into the code itself.
So cool. Where do I start from?
Yeah, sure. So we can start from the main activity just to show some of the actual. Okay, brilliant. So, of course, like with most with most starts in Compose, we have the main activity there, and we have our screen inside one composable. So if we open up the Jetpack screen composable.
Okay.
Great. So the screen there is, like we said, it's like a combination of different composables. All of them are pretty straightforward. Most, if you've kind of used Compose before, you would take a look and you'll know pretty much most of them that are there. For our own purpose of the custom layout, we can actually, if you scroll down a bit.
Yep.
Great. So we have the jet lagged time graph, which is the last composable in our jet lag screen. So we can actually take a look, go into that one.
Wait.
Oh, sorry, the jet lag time graph. Yes, exactly.
Yeah.
So brilliant. Cool. Okay, so this is the entire time graph. The time graph is these three components that we just talked about within a custom layout. So I think the way we can kind of start looking at this is by thinking about like which input, like which parameters, which kind of input this custom layout would need. And as we mentioned, like we said, we have the hours at the top, right? We have the day labels and we have the sleep bars. So for this purpose, we can actually state those as the main input for this custom layout.
Okay. So you have some metadata that goes with the day items count, I guess, if you want to have more than a week or something.
Yeah, exactly. Yeah, this is the part where we kind of open it up for reusability, right? So we can either, I mean, if we just want to display days, then we could kind of, hard code this to 7. Well, I mean, 7 in an ideal scenario, right? You might not have data for the whole 7 days. But also we want to open it up for potentially weeks or months or something like that. So you can actually pass in the total count of, in this case, days that we're going to be displaying. So, and that is actually going to tell us how many rows we have in our time graph. So we need some sort of a metadata, like you said, to actually specify.
Because then you will invoke the composable lambda with the index of the day from 0 to day items count -1, right?
Exactly. Yeah, and that kind of helps us then match the day label with the sleep bar specifically based on the index.
Okay. Is this where we mention the concept of slots?
Yes. Yeah, basically, yeah. For the custom layouts, you mean the slots?
Yeah.
Yeah. That's the beginning of the custom layout. So yeah, so I think if you look at like the second, so once we have this passed in, we can actually specify how many labels or how many bars we're going to have. So as we've set up the input now, we have the hours header that's just one composable, right? You actually, if you take a look, we're going to specify it as one composable. And then also the day label, we're actually going to exactly. And then the bars we're going to pass in as, well, we'll show that later, maybe not introduce it right now.
Okay.
So for this purpose, the first thing that our composable time graph is going to do is it's going to actually calculate how many day labels and bars we need to pass. So we're actually going to do this in the first 2 lines of the code. We actually do like a simple repeat based on the day items count. And we just, add to this sort of a list of composables, we add the day labels and we add the bars. In our sample app, the way it's displaying now, we actually have 7 of them. So just to match the concrete numbers with what this function does. Great. Okay, so now that we have like the day labels list of composables and the bars list of composables matching to the data that we're passing in, the next step, which is the first step in creating a custom layout, is calling the layout composable. Yes, that's the one. We can actually open it up. It might be also easier to show the documentation. Great. So yeah, so the layout composable actually, there's different kinds of layout composables. There's one that we use for leaf nodes, which is leaf layout nodes. It's at the very top, I think. This is the layout composable that we use for layouts that don't really have any children, right? So it's for the actual leaf nodes in the compose tree. The one that we're using here is a layout composable that's pretty much like the core component used in Compose. So all of the layouts that we know, like row composable and many others, they actually use the layout composable. So it's like a very important bit of Compose there. In our case, what we're going to do is we're actually going to use a fairly new layout composable that accepts a list of content, so a list of parameters. Yes, exactly. So it means that it can take in multiple composables as content, and then you'll actually be able to match. So, for example, if we pass in 3 different composables as list, we'll know exactly which one we're using within the custom layout. So it's something that was missing from Compose previously. It was added recently. And one thing to mention is because previously there wasn't really an easy way, or at least not a nice way, of matching your specific composable that you're passing and using within the custom layout. People were using subcompose layout to do this.
Oh, okay, yeah.
And I mean, just to be able to match a composable like to a specific, either an index or type of a composable, using subcompose layout just for that is completely wrong. That's not why you should be doing it, but it was easy and it was, it was there, so people were misusing it. So right now, the reason why I'm mentioning this is to raise awareness. Don't use subcompose layout for this. Subcompose layout is it's meant to be used for something completely different. It's the basis of layouts such as lazy row and lazy column and box with constraints, where you actually defer the composition phase into the layout phase, and it has some performance. It impacts the performance of it quite a bit. So yeah, steer away from subcompose layout for this.
So this is one of them. Don't listen to Stack Overflow kids. It's not the correct answer anymore.
Exactly. Precisely. Exactly.
Yeah.
So we can, if we have some more time, we can talk about it a bit more. But yeah, just wanted to send a disclaimer this way. Great. So yeah, so pretty much for starting out with a custom layout, we call this layout composable, and in our case, we decided to showcase this new API and pass a list of composables. So how it works is we said we have 3 types of input, 3 main composables that we use in this custom layout. It's the hours header, the day labels, and the bars. And we pass this as a list of content to our custom layout. Now that we've kind of passed it in, we are actually able to use it further down within our custom layout in its 2 main phases that it does. The first phase is the measurement phase of the layout, which means that we take in our content and we measure all of these composables individually. We assess and we set their size. It's one of the main things a layout should be doing, and it's pretty much the same approach as in the view system, which is you'd have the on measure if you remember, if people remember the olden days of using views. Not going to talk about views. Great. So yeah, so now that we've kind of passed in this content, the next step would be to actually take all of these individually and measure them. So for this specific purpose, the API of the layout composable provides us with this list. Hours header measurables is a mouthful. I can barely say this, so do me a favor, Seb, and just highlight it without me having to pronounce this.
This
Great.
thing.
This thing as well. Yes, exactly. So now we actually have measurables. Measurables in Compose means a component that is ready to be measured. It means that, exactly. Yeah, so we get the content within the custom layout in this form of a measurable, and now we can measure it, right? So the next step in our custom layout is to do precisely this. One thing to note, there's a very handy thing. It's just like an FYI. If you take a look and see at the require function within the, So it's very handy to have something like this. It's like a constraint that you can put. For example, for our purpose, we wanted to say, okay, so the hours header measurable, it can only be it can only be passed as a single composable to our custom layout. It means that the hours header measurables, that list that is being passed, it can have a size of 1 only. If it doesn't have a size of 1, then we actually throw an exception that says this composable should only emit 1 composable. So yeah, it's like just a handy thing that you can put in as a constraint to your custom layout in case you want to. Great. So, okay. So because we said that we actually just want one hours header measurable, so it's going to be like a row of different hours. The first thing to do is to actually grab the first element from this list. So we have the hours header measurable and we call first on it. Yeah, it's there. Yes, exactly. Because we know it's only going to be one. So we just, go around the system and we call first.
Sorry for the slow reaction. I was trying to keep the trolls at bay in the chat. Someone is having ideas.
Okay, that's good. I'm trying not to look at it because I know that I'm gonna get like super confused if I look at the chat. Like
just focus on this. I'll take care of. They were proposing, what if we ban the word composable? It's like, no, we cannot explain anything.
Can we, if we're gonna vote on that, can we ban measurables because it's super hard to pronounce it?
I mean, sure.
I vote.
You're a guest, so you can or cannot abide by the games that we make, that we play. But
is there
if you want to not say measurable and you want to say, I don't know, banana, I'm fine with banana.
Hours header banana. Okay. Doesn't sound weird at all. Great. So yeah,
Alejandra saying take a shot every time you hear measurable. Ale, we're gonna be drunk in 2 minutes.
Well, yeah, I'm drinking coffee. I could kind of work my way around the shot, but maybe for the yeah, exactly.
Bottoms up.
Bottoms up, exactly. Cool. Okay, so now that we grabbed the actual hours header from our list of composables that we passed in, we essentially want to measure it, right? So that's the next step. We call the dot measure with constraints. Now, the constraints are actually the constraints that are coming from the parent, right? The size constraints that go from top down, and they're passed from the parent to its children. So in our case, what we want to do is we actually want to leave the devs using this custom layout to pass in the size of our hours header measurable. That means that we open it up for them to define the size, and all we do is we take the incoming constraints and we measure it with those constraints. So we don't do anything weird with the size of the hours header. We don't change it. We don't, adjust it. We just pass it as it is, and we measure it with those constraints. And once we call the dot measure, it means that we, in return, get a placeable instead of a measurable. So it goes like this. You get a measurable, you call dot measure on it, and you get a placeable in return. Measurable means it's ready to be measured. Placeable means it's ready to be placed, right? Yeah. Exactly.
Well, I mean, this thing has a get, right? There's a get method, the placeable thing.
The placeable?
That is, yeah, I think it is
In
there
the
is a property with a getter, right? Somewhere.
are you referring to
Yes.
you're referring to the document?
It's an inside joke. Don't worry.
It's an
Don't
inside
worry. Don't
joke,
worry.
sorry.
Okay, well, let's move on. Let's move on. Let's
Yes.
move on.
I have no
So
idea
it-
what's going on.
Yeah, it's super. Let's move on.
Let's move on. It was
Thank
such
you,
an
Eva.
inside joke that it took me a while to remember it. That's how inside it was. Great. Okay, cool. So yeah, now we have the placeable, so it means it's ready to be placed. Now, as we mentioned, like in custom layouts, the layout phase of Compose actually consists out of two phases. It's the measurement and it's the placement. The measurement one, the important thing to mention here, I think it's super useful, is that in Compose, we only measure children once. So we only do the measurement pass once. And in the view system, this actually wasn't the case. So the on measure could have actually been called multiple times. And in Compose, actually, if you try to measure something twice, it'll actually throw an exception. So it's one way of optimizing for performance in Compose, which views don't have. And actually, this measurement pass, if you have a lot of children and you run a lot of different measure passes on all of these children, like it can impact the performance quite a bit. So in our case, you only have measure called once. Now, first off, how custom layouts work is you need to go through the measurement phase first to go into the placement phase second. So it's only done in that specific order. And the way we actually constrain this is through different scopes. Scopes are heavily used in Compose, so it's not a new thing. So when you're in the measurement scope, you'll be able to do the measurement phase there. Once that is done, you get placeables and you get to use them in the placement scope. This means the scopes actually mean that they constrain you from, calling measure on a placeable or the other way around. So you won't be able to do that. It means that it gives exactly. So you have the measure scope, and then within it, if you take a look at the layout, exactly. So you have at the very bottom, you'll have the placement scope, which is basically nested inside the measure scope. And that's how we handle the ordering for this, which is quite cool because there's no, room for making weird mistakes that are
the typing forces you to put stuff in the right order, essentially.
Exactly. Yeah, precisely. Which is kind of cool. Well, at least I thought it was cool.
It is.
Yay! Thank you, Seb. Cool. Okay, so the next step is the day labels, day label measurables, right? So these come in a form of multiple day labels. So compared to the hours header, which we only had as like one row, day labels are actually going to be passed in as different amount of composables in one. So we have a list. And what we want to do with this measurables is measure them one by one. So we call .map and we get the measurable item inside the map method. So again, because we want to leave the actual defining of the sizes of these labels to the user or the developer, we only measure them with the incoming constraints as they are. We don't want to, do something weird with them. We don't want to change them. We just get them as they are. We measure them with this specific size, and then we create a placeable from it. So same principle here. We get this specific item in our map method, and we call the dot measure on it with the incoming constraints, and we get a placeable in return. And once we iterate through the entire list of day labels, we get the day label placeables, which is basically a list of placeables that are now ready to be placed. So we have 2 out of 3 done now, right? The next one is the actual bar placeables, right? Mm-hmm. So these ones are a bit more tricky, let's say it like this. So while these 2 were completely independent in terms of sizing, it means whatever the size you set them, that's the size you're going to get. But for bars, we actually want our custom layout to determine the size of a specific sleep bar based on how much the user has slept, right? So if the user has slept on a Wednesday from 9 to, 6, 7 a.m., we want the bar to be as wide as those days, right? So we need to do some calculation in this case to be able to determine the sleep bar. So in order to determine the size of one single sleep bar, we need some sort of information about the user for this specific sleep bar. So first of all, we need to know how long they've slept per day, and later on, to place it properly, we'll need to know how much to offset it from the start, because that will be the sleeping start hour. So for example, for the offset of the first item in this custom layout for the Wednesday, we actually need to know to offset it to the beginning of 20, yes, exactly, the 9 p.m. So, but this is something that we'll do in the placement phase. But just as an FYI, those are the two key missing information that we need. So in order to kind of tackle this challenge of passing specific data per specific composable, there's a really cool API that's called parent data modifier. And in here, we actually call it time graph parent data.
So we're accessing it as the parent data from the measurable.
Yes, exactly. So each, we can go into time graph parent data maybe first so that we can explain what we're doing here. Yeah, great. So what is parent data modifier? So basically it's like a channel of communication between a child composable and its parent layout composable. It means that every single child composable has some sort of a unique information that it needs to relay to the parent layout composable for it to know how to either measure it or place it. And that's the use case of using the parent data modifier. So the parent needs to know something very specific for the child to know how to place it and how to measure it. Now, I mean, one way of avoiding this would be to actually pass like a list of hours or a list of offsets into your custom layout. But you need to know that then you're opening up your custom layout to vulnerability in terms of not matching the indexes properly. So you could take, I don't know, if your data comes in a random order, how are you going to match, certain offsets with a specific composable? So in order to avoid having to map, send weird data into your custom layout, using parent data is actually going to help you with this, because then every child composable pretty much gets shipped with its own metadata. And this is how it passes it safely to the custom layout parent. So how do we do that? If we go back to the implementation, great. So we just, sorry, at the very bottom of the time graph. Yeah, exactly. So it's very simple. So you just, implement the parent data modifier that's already there, and you override its modify parent data function. In this case, what we want to pass is the duration and the offset of our child composable. So it means every child composable needs to pass its duration and its offset to the parent. And that's how we define parent data. What do we need from the child composable? Added as input to this parent data. And modify parent data means that we just pass it. We pass this information from the child to the parent. So that's all you need to know in terms of how to define it here. The interesting bit is how we actually pass it from the child to the parent. So if you take a look at where we're actually using this.
I think I got into the wrong.
Yeah, the time graph. Yeah, exactly.
Oh, then here, I guess.
So how we actually do this, how we actually pass this specific information, or this, let's call it package, pretty much package with this sort of information, how we pass it from the child to the parent layout is through a modifier. So when we're actually calling this composable, we're actually going to call it with this time graph bar modifier that's actually going to relay the information back to the custom layout. So there's a lot of implementation detail here. I wouldn't necessarily want to go into this. All we're doing here in this function is calculating the duration and the offset manually. So this is, again, just implementation details. If you want to go through this one by one, it's interesting to see how we actually calculate it, but I don't think it's necessary to go over the whole.
The point is, this is the important part. Like
exactly.
the fact that you define a modifier that you then apply to the slip bar composables.
Exactly.
And then inside you do then, and then just pass in the time graph parent data, which is a parent data modifier.
Exactly. Yeah, precisely. So we have like the package, we define how we send the package. And if you take a look and see how we call the time graph modifier, where it's being used. So yes, the modifier. Yes, exactly. So you can see that here in our Jetpack screen, when we actually call the sleep bar composable, we set the modifier time graph bar, and then we pass this information to it. Yes, exactly. And that's pretty much it. So we have, this enables us to get the necessary information in the custom layout in return. Now, one thing we didn't actually mention during the talk, because during the ADS talk, because we had like 10 minutes for a custom layout. So we had to run through everything. And I thought personally that this is really cool. So if you kind of think about this, we create a custom modifier called time graph bar, but there's nothing in this modifier that constrains it to using it just on a specific composable, like a sleep bar, right? You could reuse it anywhere, right? And it wouldn't really do anything. And in Compose, we actually rely heavily for modifiers. We rely heavily on something called, on some sort of type safety for modifiers. It means that for specific composables, like for example, the box composable, which has the match parent size, this is a modifier that cannot and should not be used outside of the box scope or the box composable. And in order to constrain the usage of this modifier just to the box composable, we again revert to using scopes. And we can kind of apply the same, and we did do the same for this specific modifier. So if you look at the time graph bar modifier, you can, yeah, that's good, yeah. So you can see that we have the annotations at the very top, which is the layout scope marker. Yes, exactly. And this actually helps us constrain this modifier to a specific scope. And alongside this, you can actually see that it's wrapped in a time graph scope object. Exactly, yeah. And this is the same principle that we apply for a box composable, for row, column, and all of the other composables that have a specific scope. And we want certain modifiers to be available just within that scope. So in this case, how we do this is we annotate we actually create the modifier within this scope object. And if you take a look and see where the time graph scope object is also being used. So the first one, we can open it, the first one. It means that we want the time graph scope to be exactly. So we want our composable bar to be of type time graph scope as well, right? So that we kind of constrain the usage of the modifier to just this composable. So for example, as a quick example, if you remove the time graph scope from the bar, exactly, and we go back to the Jetpack screen, see, we won't be able to use it because it won't be available for this specific composable. We only constrain it to the scope, which means that we also need to define our input within the scope as well.
And then I noticed that down here, so what you're essentially saying is that the lambda, the composable lambda that emits the composable for this slip bar is as a receiver, which is the scope that we want, because the stuff that we do in there needs this modifier because we need the data to then be able to lay out properly the bar.
Exactly, yeah. I mean, it would work without it as well. So we wouldn't need to necessarily go through this step of defining a scope and constraining it to a specific scope. But that means that you'll be able to then unnecessarily try and use this modifier on some weird other, composables in your code, and it doesn't make sense. Like, why would you do that?
It doesn't do anything, right?
Exactly.
Unless you explicitly look for it, then, and obviously this is custom, so only makes sense where we read it.
Exactly. Yeah, precisely. So it's like a nice way of, using the power of Compose and the modifier type safety to your advantage, basically. Sweet. Okay, so now we actually have this information for our bar placeables, right? We have the duration. Exactly. And this is how we fetch it. So again, we call the map function on this list of measurables that we have. And for every single measurable, we grab the duration. And then again, just implementation details, we do some calculation to calculate the bar width. Mm-hmm. So once we have the bar width, that means that we actually have the necessary information to measure this item. So for every single bar measurable, we call the dot measure on it. And then we copy the remaining constraints. So the height is the same. We don't want to change it. Whatever is being passed, the height is going to be the same. But the width is going to change based on our calculation, right? So we set its minimum and maximum width to the calculation that we just made. And that's it. For the rest of the steps in this specific case, all we do, if you see at the total height below the constraints, the copies of the constraints, So this is just the way we kind of track through our custom layout the total height of our custom layout. It means that we just grab the height of this specific bar and we add it to the total height. So this is just a step along the way that in most cases, you'll need to do this step in the custom layouts, is track the total height and the total width. It's just an additional step.
In this case, you don't need to keep track of the width because it's the width of this column plus the width of this row, right?
Exactly. So it's not fixed, but it's dependent. It's defined by the actual days and the rows, right? So that's all we need. It won't be as dynamic as this will be, as the height. Cool. Okay, so we've measured the bars now. So in return, we get the bar placeables. So for us, the measurement step is now done. So all three components have their sizes set at this step. So once the measurement pass is done, the next one is the placement pass. Mm-hmm. And in this case, the placement pass starts by calling the layout function. That means, and you can also see, like in the extension of that row, you can actually see that you're in the placement scope. Precisely, yeah. So to call the layout for the placement scope, you need to pass in these two total width and total height variables that we've been kind of tracking along the way. So it's just to define the actual size of the full layout of the custom layout. And then within that size, we define where to place each of its children.
Because right now we only know how big they should be. But we don't, if we just said, oh, we're done, then they're not actually put anywhere. They don't know where to draw themselves.
Exactly. Yeah, precisely. If you kind of didn't call this step, you'd get a blank screen pretty much, because you had your, and if that's what you want, then great. But in case you don't want a blank screen.
Sounds like a lot of wasted effort at this point.
Yes. Exactly. Yeah, pretty much.
But it's super fast.
Yes, very much. Yeah, I would say so as well. And my ADS talk would be much less demanding to write if we kind of stuck to a blank screen. If you call it without calling the layout function, then you just get a blank screen. But the next step, as you said, you have your children of the layout defined with its own sizes. So now we need to figure out where to put them. And if you remember, like for just as a small repetition, Compose consists out of 3 phases, right? It's the composition, the layout, and the draw phase. So actually, once we're done with the layout and we decide where to, how to measure and how to place items, the third step is actually to render them on the screen. So yeah, you need to know where to place them for this. Cool. Okay, so we can go into the placement scope actually now. So in order to kind of define where to start placing things, right? In this case, you would need to figure out your X and Y starting coordinates, right? To know, where to start listing them. So in our case, the X position is actually where our day labels width starts, right? So in our case, not the X position, but yes, the X position, where the width of the day label ends. So this is where we actually start placing the children of our custom layout. And for the Y position, it's the same, but only for using the hours header and its height. So those are the 2 starting points.
Here we are essentially, so I think one important thing to say is that the origin is at the top left corner. So when we're talking about X, we're going this way, and we're talking about Y, we're going down this way.
Yes.
And what we're doing here with X position and Y position, are we calculating where this point is?
So if you, this is where I need a pointer, right? So we're trying to actually figure out exactly where to start listing our the children of our
all of them.
custom
Okay.
layout. Exactly. So the actual the X position would start at the start of the hours header, right? And the actual Y position would start at the top of the day label, the first one. So those are our starting.
Yeah, because the header starts where the labels finish in terms of horizontal, and in terms of vertical, they start at the very top at 0. Okay.
Exactly. Yeah. Sense. It's a bit confusing, because we can't really display it. In the IDS talks, we actually pinpoint the exact spot, so it's a bit easier to visualize it. But yeah, pretty much the reason why this is kind of inverted from what we might expect is because of the dependence that these items have on each other, right? So we want the day label to start below the header, and then we want the day label to start below the header, but we want the header to start after the day label, right?
Yeah.
So that's why, again, for the custom layout benefit of using this, this is actually, a really good reason to showcase why you need a custom layout, because these two are completely dependent of each other and their own sizes. Cool. Okay, so we have the starting points, the X and Y, right? So in this case, again, a good way of approaching the placement phase is thinking what elements are supposed to be independently placed. So it means that we don't really think they either don't have any dependencies on other elements, or they have the least amount of dependencies. So in our case, actually, the hours header placeable, once we have the X position, which means its starting point, it's pretty much independent, right? We only want to place it at the very top of our custom layout. So to do that, we call the .place function on it. And we can call it because we have a placeable. If this was a measurable, we wouldn't be able to call .place at all, because Compose wouldn't let us to do that.
Because scopes.
Because scopes, exactly. Yeah. Scopes are super cool in Compose.
Essentially, I'm going to use a bad word here. We have to build a dependency graph of the various coordinates of the various things that we need to lay out, and then resolve it starting from the part of the graph that is independent from the rest. It's kind of like a mental puzzle kind of thing.
Exactly, yeah. And I think pretty much if you're building a custom layout that that's mid-level difficulty to hardest difficulty, then I guess you always need to think about these things. You need to sit down, work with your designer or whoever you're working with, and kind of map out the behavior that you want before you dive into coding, because it helps you build it in a much better way, because you kind of think about all of the dependencies, the specific kinds of behaviors, what you need to be, what you need your custom layout to be. So yeah, it makes sense to kind of invest a bit more time into thinking about these use cases and scenarios.
Sorry, I mean, you say something that it confused me for a second. So what do you mean
even.
you need to sit down and talk to your designer? Do you talk to the designer?
Or they talk to you.
Yeah, that's the thing. Do they talk you back? I mean, that's how does it work? Because the only one that always talk to me is Chris, but he does it out of like because he's polite. That's how. It's it's out of pity. I don't know for sure, and I don't want to know for sure. No, but jokes aside, I keep hearing about the scope thing, and I keep remembering that I want to comment with that thing is very cool, because I was expecting something failing at runtime, but actually gives you an error like in Android Studio. So I don't know if it's like a gimmick or something, that it is not an actual compilation error, or it's more like a warning that is red. I don't know how it works, but it's actually very nice. For a moment I thought that you were showing some context receivers of sort, to constrain the types, but it's super nice. And
it's very
I like
cool.
The constraints are, I mean, they make a lot of stuff easier to work with. When it's a bit harder to make a mistake, I'm happy. So that thing is super cool.
Yeah, exactly. I totally, that's why I'm kind of geeking out about them, because like if you remember, like in Views, we didn't actually have this. You could, in XML, you could throw around different layout parameters and, just add them to whatever, and it wouldn't work. And you wouldn't know why it wouldn't work, right? Because it just, it just disappears somewhere along the way, and you don't know why it doesn't work. But here, you specifically know, like, while you're writing it, that it's not going to work because it's red.
Yeah, I think back in the day, I don't think you could do it after some point, but in the very early days, if I'm not mistaken, with Views, you could actually measure something in on layout, which is a big no-no, because you were still acting on a view. It's like, view.measure, here's the constraints. But you can do it at any time because it was not scoped, because, well, you couldn't do it with Java to begin with, but also it was never thought about. And then I think at some point later on, they added some like state tracking into view.java that would explode if you tried to call measure while you were in the layout phase. Unsurprisingly, I mean.
Yeah, exactly. And then on top of that, you could call .measure multiple times, right? And then invoke even more explosions of your. So yeah.
Kind of thinking of cool guys don't look at explosions, and having explosions in the background is walking away as you do the pull request. You're like, I'm done.
Sure. Works on my machine.
Yeah, exactly. Geeky version of Die
it runs on my Xiaomi. I don't care, right?
Nice. I totally agree. I think scopes are very cool, and I quite liked experimenting with them on this specific example. But yeah, like, we can move away from the scopes now.
Yeah.
We talked about it so many times. We can do shots on saying scopes as well, and measurables.
I don't know. It's like, do I really need to be drunk on stream?
No.
That much?
It's your stream. You can do whatever you want.
I mean, sure. Technically, I could, but I think the real question is, do I want to?
Probably your.
Do you want to go to the pub? Yes. I'm happy to go to the pub, but there's a time and a place.
Not streaming it.
Yeah.
Nice. Cool. Okay. So yeah. Where did we stop? I forgot. Oh, okay. Hours header placeable dot place.
Yes.
Cool. Okay. So as we said, like the one above, actually.
Right.
The
Yeah.
hours.
Sorry.
Yeah.
Yeah.
Yeah. So we said, okay, so we have the hours header composable, which is like one single row. All we want to do is place it at the top after the day label. So we actually use the X position to do that and 0 as Y because we want it at the top, right? So
Yeah.
that bit is done. Header is actually placed within this after this function is called. Now, the second one that we want to place are the actual bars. The reason that we're starting with the bars and not the day labels is because we actually, if you tap on a sleep bar and it expands, can you please do that, Seb?
Right.
Okay. Yes, thank you.
Yes.
So once we kind of do this, we actually realize that we want the day labels to be dependent on the sleep bar because of this expansion. Because if they're not expanded, then it's totally fine. They're all like in one row, right? They're all aligned. But when we tap on a sleep bar and it expands, we actually want all of the day labels below it to, shift downwards as well. If we didn't have the dependence, we'd actually expand the sleep bar, but the day labels would remain, one after another. So there is some actually dependence here. The day label needs to, follow the bottom of the expanded bar as well. So there's actually some dependence here.
This is interesting because the bars position depend on the day label's width. So on the
Yes.
horizontal axis, the bar depends on the day label, but on the
Exactly.
vertical axis, the day label depends on the bar, on the previous
Exactly.
bar, technically, I guess.
Exactly. Yeah, precisely. Again, a way of justifying why we're using custom layouts because this would be really difficult to achieve just using regular composables. And even if you did achieve it, chances are nobody will be able to review it properly because it would be super complex, unnecessarily complex.
Yeah.
So yeah, okay. So we have the bar labels, the bar placeables now. So in order to actually measure them, we call the for each or the for each index so that we also get the index of the specific item,
in
right?
order to place them.
Yes, exactly, because we actually want the index to match. Well, we'll show later why we want the index, but let's go step by step. So once we go through every single bar placeable, we actually use the time graph parent data again. So in the measurement pass, we were fetching the duration of every single bar, right?
Yes.
Exactly. But we also said, okay, we need the duration, but we also need additional information, which is the actual offset. We need to know how much to offset it from the start to know where the sleep bar is supposed to, start, what time of the day it starts. And this is, again, another piece of information that we decided that we want to pass. So once we're calling this composable and passing it as input, we actually pass the duration, the offset with it as well. And that actually helps us calculate the bar offsets. Again, just, implementation detail, we can kind of skip that part for now. But once we have the offset from the time graph parent data, we actually calculate the bar offset. And that's what we use for the placement phase. So we actually place every single bar placeable using the X position, so the actual starting point where the day label ends.
At this point.
Yes, exactly. And then we add the offset of each individual child bar placeable. So the first one starts at 9, the second one, the Thursday one, starts at 11, etc. So the offset is, different for every single one of them. And then we call the dot place on it because that's all we need, right? We need the X position, the bar offset, and the Y position. And that's it for the bar placeables. Now, the reason we haven't finished this step is once we actually place the bars, we know where and how to place the day label placeables. So how we know that is we need to use the same as the comment says, right? The day label actually depends on the size of the bar. So we actually need to use the same Y for both of them. And that's why we kind of want to stay within the same step of placing the bar placeables, because we want to take the same Y position, match the index of every single day label, get the index of the sleep bar, and then match it with day label. So for example, if we get the first, the index of the first sleep bar, we also want to get the first day label as well. If we get the second sleep bar, then we also want to get the second day label. So that's how we match them one by one. We fetch that day label with that specific index, and then we call the dot place on it. So we place both the sleep bar and the day labels in the same step.
And we know that the day labels always start at 0.
Exactly.
Horizontally,
Exactly.
and then we know the Y position because it's the one we calculated.
Exactly.
And then we keep track of that, as you were saying earlier. As we lay things down in the layout, then we know, okay, so we have gotten, 10 pixels down. The next component starts at 11 pixels down.
Precisely, yeah. And the Y position is super important here to keep it in the same step, because the Y position is going to be different depending on whether a bar is expanded or not, right?
Yeah.
If it's expanded, it's going to be one size, and if it's not expanded, it's going to be the other size. So this Y position and it's the fact that it changes based on whether this is expanded or not, we need to know this specific size to actually set the day label and push it downwards when the sleep bar is expanded, and keep it aligned when it's not.
And doing it this way also means that while it's animating, it can push everything around based on the different, because maybe this bar composable here is growing the size from collapsed to expanded. So for every animation frame, it will relay out and know that this is changing, this is changing, this is changing.
Exactly, yeah. It gives us a really nice, smooth effect. And yeah, in essence, then it works as expected, because you don't get any weird, misalignments in this case. So once you kind of call the dot place on both of these elements, that's it. You have all of the 3 elements, measured first and then placed properly. And yeah, if you run it, then you get what we see in the screen.
Nice animations.
yeah, exactly. The second part to this, of course, if we just take a look at the custom layout in this specific app, we just display the header, the day labels, and the bars. The bit that is, that looks really cool, the emojis, the gradients, the animations, the expansion of the sleep bar, and showing the different time dates, it's in a completely different section. So I really encourage people to take a look at the code, because Rebecca Franks, who is my colleague, and
she's in the chat. So
she is. Oh, sweet. Hi, Rebecca.
So, Rebecca, if you want to come talk about that.
Exactly. No, it is really cool, and she's done a really cool job. So I would definitely encourage people to take a look at the code, because there's some really interesting stuff there. And that part is also covered in the ADS talk in the second part of it. So yeah, but maybe Briggs can come and do her part as well, because we had only 10 minutes for each section. So I'm guessing, as you can see, this almost lasted an hour and a half. So I'm pretty sure she'd have a lot of really cool things to say.
It's perfect timing, because then now we know how it works. We have a good understanding of how you can write a layout. Obviously, depending what you want to do, the actual logic for the layout is going to be different. But the basic idea of measure, and then you get placeable, you place the placeables, and then you have your layout is done. Like the idea of the layout composable is just that you know how to do this stuff.
Exactly. It only comes down to measure and placeable. Measure and placement steps, and then within those you figure out. You sit down, you talk to your designer, or he talks to you, she talks to you, and then you figure out what you need to do.
Or maybe you talk to yourself because you're the only person in the company.
Exactly.
That also happens.
Precisely.
Consult a professional. I have a question before we go to the Slido. Just as a reminder, everyone, if you have questions about anything we have discussed or anything layouts in general, just ask that in the Slido. We're going to get to that in a second because we have about 15 minutes for that. I have a couple of questions about decisions you've made in here. For example, the fact that you use the time graph parent data and you populate it with like you do the calculations in the modifier instead of just putting the raw values and doing the calculations at layout time. Is that to cache the result of the calculations and save some time? Is there some other reason for that?
To be fair, for this specific reasoning, we didn't, we only did that there because it was the easiest to showcase how you could actually use the modifier to do the calculation. There wasn't any, specific reasoning in terms of caching or anything. Yeah, it was just, showcase what your custom modifier could do and how it relays this information back to the parent.
Got it. And then I had another question, but I kind of forgot it, so it's fine. Should we look at the Slido? Let's see, Slido, I don't know. Anyway, we have two questions, both from Fabio. Fabio, you have many questions. So let's start with the one that has the upvote. Can you please give us some guidance on when to go custom? For example, sometimes I just need to align composables in a more custom way than what a row allows. And I guess the rest of that is this a good use case or not?
I mean, in a more custom way is a very broad definition. So I guess it would
depends.
Yeah, exactly. The answer is it depends. Yeah, exactly. So I would say that for going custom, the specific question is how dependent are the children of each other, and dependent in a sense of, do they need to know about each other's measurements to do their own measurement? Do they need to know where do they need to be coordinated in terms of placement? Are they heavily dependent on each other? And as we've seen in the custom graph that we just built, it's a combination of all of this. So we need a lot of coordination between different elements for both the placement and the measurement. So this is, in this case, it would be ideal to have this sort of a custom layout for this use case because of this, codependence of all of these elements. And on top of that, we need to do some serious calculations, on placement specifically based on this. So I would say this is like a way of thinking about custom layouts. Obviously, if there's other ways you can go around defining, for example, individual children within a row or a column. If you want to change the size or the placement of just one child, you don't need to call a custom layout. There's actually a .layout modifier that helps you do the same thing, but just for one child. So for example, let's say we have like a list of items within a column or a row. Let's say that 99 items from that list need to behave in a certain way, but you just want one to escape the rule from this list. You can actually call the .layout modifier on it rather than having like a custom layout that just changes one child. So there's ways around this if you don't need to go fully custom. But I would say that if you have a use case where your children are heavily dependent on each other, I think that's like one way you can look at custom layouts.
Okay.
Cool.
We have, I guess, a follow-up question on that, which is also something I was thinking about, which is, what is the relation with then constraint layout? Because maybe if you're starting, especially if you're coming from views, you might think, oh, I can use constraint layout because I know about it. Is there anything particularly obvious and universally applicable that we can
Yeah.
say?
I think for constraint layout in Compose, it's a bit of a tricky thing to answer. Constraint layout is one in Compose is a way of it's very useful for migration purposes, actually. So if you're coming from the view system and you kind of, either are migrating your code one by one, or you still haven't gotten around to diving into Compose fully, constraint layout is a good way of bridging this gap, because you can, continue to use constraint layout in a similar way that you've used in views, or you can, help yourself ease the migration path by kind of sticking to the, to what you already know. And constraint layout, it works in a very similar way in Compose as it did in views, by defining certain constraints. So I would say it's like a good middleman, like a middle phase between moving to Compose. But because custom layouts are so easy to implement, depending on your use case, I would always say that you can kind of,
I mean, that's in general, they might not be that easy, but if you have a very narrow use case, then doing a custom layout is way easier than it used to be with views.
Exactly, yeah. And with constraint layout, what you do is most of the time you actually focus on the actual placement of it, right? So that's how you define it. And custom layouts, expand on this. They give you ways of manipulating children's, sizes, figuring out, if child A is this size, then child B can be this size, etc. So it just expands on the concept of constraints a bit more.
Yeah, the power of being able to say, if this happens, then do that, is super important. And you can implement like a responsive custom layout based on breakpoints, for example, where you say, oh, the space I have available is, I don't know, 1,000 DPs, so I can show more stuff, or I can show stuff in a different arrangement that I would otherwise. And that's just a when statement or an if else statement.
Exactly, precisely, yeah. Cool. Any advice on what should we avoid doing regarding the performance while building the custom layout? In terms of performance, well, the major thing is already kind of done for you, right? It's the measurement pass being done only once. So it's not something that you can't, again, as we mentioned, if you try to do like a measurement pass twice on the same thing, you'd get an actual exception. So that on its own is already, performant enough. For custom layouts, nothing specific comes to mind, because I think the biggest way of avoiding any performance issues is actually using custom layouts rather than using sub-compose layout, which is, as we mentioned, is like a very common thing to do. So I think that's actually the biggest performance gain you can get. Try avoiding sub-compose layout and reverting to custom layouts on their own. So nothing specific actually comes to mind that you need to keep. Yeah, I don't really know anything that you need to keep in mind specifically.
Maybe the only thing we can say is the generic advice of, if you can cache the value that you're going to use multiple times, then it doesn't make sense to measure the same thing a million times. Just measure it once and then keep the value in a variable or something.
Yeah, of course. Yeah, you can play around with remember and remember savable in this case and see if there's any input that you need persistent.
Okay. Do you think sticky header started as a custom layout that was adopted into Compose? Do you know?
Sticky headers, as in the actual API that we have for lazy lists. I guess that's what they're referring to.
Probably.
Yeah, so we do have an API for sticky headers for lazy lists and grids. However, they're experimental, and there's some work that we want to do for this API before it goes out of experimental. So for the time being, There's no comment on this. I don't know how it started out. If it started out as a custom layout that was adopted into Compose, I'm not very sure of the history of this API, but I guess, yeah, I don't know. I don't know its history.
We'll find out and ask whoever wrote those.
Yeah. Could excessive use of custom layouts cause performance degradation? No, not really. No, because custom layouts, the way we kind of build them is very similar to what, not very similar, it's almost identical to how the rest of the out-of-the-box composables are built. So we use the same layout composable as they do. In that case, I mean, excessive use of custom layouts would not, if it's built in the proper way, right? And if it's if you take advantage of like you said, like memoizing certain calculations and building it in a way that's fit for your use case, there's no performance issues that you can come across. Actually, we kind of pride ourselves on saying that Compose is like very performant if, of course, you test on release, not in debug, right?
Very important caveat.
Yeah, with right optimizations enabled.
Yeah.
So yeah.
Not mining crypto in the layout phase also helps avoiding performance degradation. Like avoid while true in your layout code, like that sort of stuff.
Exactly. Yeah. Nice. Cool.
Well, we are perfectly on time because we have 5 minutes to wrap things up now.
Nice.
I want to thank you. Obviously, it was very good. I have learned a lot of stuff, which is always good. And it's kind of the whole point why we do this, is to learn things together. So thank you very much, Simona. And
thank you.
I hope you had fun.
Yeah, it was super
fun. I hope
fun.
the nervousness went away.
Yeah, I was gonna say, yeah. Don't say that. But no, this was super fun. Thank you very much for having me.
Thank you very much for coming. Ivan, the floor is yours.
Yes, let's do the wrap up. I'm gonna also try to do this. I don't know if it still works. Subscribe. Is it working?
Yes, it's working.
I love it. I love it. Well, I'm building the tooling, so I love this. And as you can see, also the bot is periodically spamming the chat. Yay!
Thank
Timers.
you, Ivan.
Timers, man. I'm loving this. So this is something that we are working with Sebastiano, and it's gonna be a bit more public in the next months, probably beginning of the next year. So stay tuned. If you want to support the channel, again, you have the opportunity to buy the stickers like this if you don't get to meet us at conferences. So you can have like something like this. You can have our latest creation, that is the most Italian Android sticker ever. Yeah, you can buy the usual pizza sticker. Just give it a shot. The coffee shop is always available, and the coffee shop also provides you the possibility to actually give us a subscription. Take a subscription, and we have plenty of tiers. A few of them allow you to access the Discord server that then you can use to reach out to the guest after the show and watch Sebastiano create this incredibly clickbaity thumbnails with this tooling. So thank you, Simona, for joining us. It was very nice. It was very hands-on, and I love this. People enjoyed it a lot. From the chat, the trolls at some point settled, and then that's how you know they are paying attention.
Yeah, they're too busy paying attention.
Yeah, a lot of fuss at the beginning, and then they just settle, and then they focus on the stream, and that's why. And I love it. So yeah, thank you again.
I think one of the trolls might be my sister, to be honest. I just saw that now, so she was probably the biggest troll in the stream, I would say.
That's the best. And if you're watching this on YouTube, please subscribe and like the video. If you are Simona's sister, please you can support us with if you have Amazon Prime.
Specifically.
Yeah. If you have Amazon Prime, you can connect your Amazon Prime to your Twitch account, and you can subscribe to the channel for free every month. Bezos is picking the bill, so let's do this. And yeah, I love it.
Okay. We're gonna see you all next week. We have J-Ro from Square talking about paparazzi. So we're gonna learn about screenshot testing. I'm so excited about that as well. Cool.
Nice.
Thank you, everyone. Have a wonderful week. Bye.